Ksp is equal to, for AgCl, the concentration of Ag plus times the concentration of Cl minus, right? And so what we need to do is calculate the Qsp, right? So we calculate what is this value right now based on these solutions. So the Ag3 concentration is 0.1 molar, you told me, is that right? So it's 0.1 here for the silver. And 0.075 for the Cl. Right? So what is the Q? So now compare that to K. So Q is drastically larger than K. Do you agree? So a Ksp equation is written as AgCl in equilibrium with its ions. So Q greater than K tells me that this reaction goes to the left. Do you agree with that? So this tells me that this will precipitate. And yes, it tells me that it is a supersaturated solution, and it will precipitate until it becomes saturated.
It will precipitate leaving a saturated solution?
Correct. There will still be some in solution, some silver and chlorine in solution when it's done, right? But those concentrations will only be whatever the square root of that Ksp is, right? Because if we write an ice table for this thing, this would be plus x, right? And so our Ksp is equal to x squared. And so we take the square root of the Ksp and we can get the concentrations that would be in solution. So there still will be some in solution when the precipitation's done, but it will precipitate down to Q equals K. That's a saturated solution.
Can you explain what exactly those are? I remember us briefly.
Yeah, unsaturated means more stuff can dissolve in. Saturated means I've got exactly the amount that can be dissolved. And supersaturated means there's too much in solution, and that won't last, right? That's an unstable thing, and you will do exactly what we just said. You'll precipitate until you become a saturated solution, which is equilibrium.